Hi, I'm Iman and welcome back. Today we're fixing a silent troublemaker in earthquakes: stairs, the Achilles heel of many buildings in past earthquakes. I'll show you why they get damaged and the details to keep them from acting like braces. Let's get to it. All right. The staircase, as a non-structural component, has been the Achilles heel of many buildings in past earthquakes. But unfortunately, structural engineers still don't fully apply those lessons when designing it. Basically, stairs are primarily damaged by inner story drifts. And the problem is that they can act like unintended diagonal braces. So your stair goes into axial tension or compression. This is from the Chile earthquake, and you can see how the cracking lines up with the stair flights. Those stairs were rigid at both floors. So when the building drifted, each stair flight became a diagonal strut. Basically, they weren't designed as part of the lateral system. So they took axial forces, crushed landings, and tore finishes. Okay? And in reverse shaking, some flights can even walk off their seats and drop. A direct threat to egress. Okay. By the way, this picture is adapted from FEMA E74. Okay, so how do we stop that from happening? The answer is simple. The practical rule is fix one end of the stair, let the other end slide parallel to the stair run. So that way, when floors move, the stair slides instead of bracing the building. And here is a detail for a steel staircase from FEMA E74. We're at the point where a steel stair stringer meets the floor. The whole idea is simple. Carry gravity every day, let the stairs slide during drift so it doesn't act like a brace. Alright, start at the bottom. This small channel with a standard hole is the seat. It basically takes the weight of the stairs. Okay. Now, look at this plate over here. See the long horizontal slots? The bolts are centered in the slots and tightened snug. The slots run parallel to the stairs. So when the floors drift, the stringer can slide back and forth instead of going into axial force like a diagonal brace. And we size the slot for the design story drift at the stair plus tolerances. It's an easy rule. So slot length is greater than or equal to bolt diameter plus 2 times required travel. Okay. At the slab edge, there is a sliding surface between the stair pans and the concrete. So don't grout this interface. We want it free to move. And during an earthquake, the floors try to move. The stringer glides in the slots and the seat keeps gravity safe. So without these features, the stairs behave like a brace and cracks landings. Okay. And here is what that looks like in the field. The slotted holes are right here, oriented along the stair. Bolts are installed centered in the slot, right? So during inspection, confirm slot length, slot tight condition, and the paint, grout, or shims aren't locking the sleeve.
wood stairs. Same idea in wood. The stair ladder bears gravity at one floor. At the other floor, a steel angle with a long slot in the vertical leg lets the stair move along the run. Okay, so use the snug, tight bolts with hardened washers. Again, the concept is identical. One end fixed, one end sliding. And concrete stairs. Most reinforced concrete stairs are poured right into the building frame, even though we usually analyze them as if they are separate. And the problem is when both ends are locked in, the flight and landing slabs behave like diagonal braces, right? In an earthquake, they attract big lateral forces and get damaged. Again, the fix is simple. Let one end slide so the stair slab doesn't act like a brace. And basically, you can build a separate reinforced concrete stair tower with a gap so it can move without pounding the main building. Where the stair meets the floor, cover the vertical joint with a tread plate that's fixed on one side and slides on the other. Or you can use a filler that can crack or crush during shaking without hurting the structure. And if you rigidly connect stairs at both floors, you're effectively making them part of the lateral force resisting system. And per ASCE 7, that means you now have to deal with a bunch of checks and design work. You can see here. All right, bottom line. Stairs fail when the slide is blocked. Let them slide and they stay out of the lateral system. If you don't, you're signing up for the full ASCE 7 design path.
Alright, that's it for today. If this helped you, please like and subscribe to support the channel. And if you know other stair separation details, let me know in the comments. Thank you.